Let's now talk about how we can remove from the front and from the end, right? This is the test, generated test I also made available to you. Let's take a look. Okay, so if you go to Eclipse, the same project, go to test generic DLL string, and this is the one to look at, right? Test string DLL remove front and end. Let's take a look. Okay, so what we're doing is, let me just make it a little bit larger. Okay, just to set up the context. Basically, this part over here is really, let me just be consistent here. We actually got two lists over here to consider. One is over here, and the other one is over here, right? We want to see two different ways of removing. Either we can just keep removing the first, or alternatively, we can keep removing the last. I think I'm going to trace both of them together with you, all right? And let me see how we set up the context. So this part over here about initializing the list, and also to really set up the contents. So this is the yellow list, right? You can think about this list is corresponding to the diagram over here, first of all, right? We are adding first Mark and adding first Alan. And the second example, which I will go through, is another list, which would be basically, actually, let me be a little bit more careful. Only this part over here is about setting up the list by two at first calls, and the second one is going to be at first also, but I'm gonna do it, I'm gonna remove it in a different way. All right, so we got the yellow list, which I'm gonna manipulate by using removeFirst 2 times, and also the orange list, which I'm gonna manipulate by using removeLast 2 times. Okay, that'll be the setup. Let's talk about removeFirst to begin with. What does it really mean to remove the first? So I'm going to call the removeFirst over here, and we're saying that, this is some exceptional condition. If this list is simply just empty, of course you cannot remove anything. So that's why it's going to be some illegal argument exception. I assume that you can understand this. And how do we remove? Basically, if you want to remove the first, you simply give the first node, which will be header.getNext always. This will be the first node. The first node. Always true. Can it be trailer.getPrevious? Not necessarily true always, because trailer.getPrevious may be referring to just the last node. In the case where the list size is more than 1, in that case, trailer.getPrevious is not going to give you the first node. Just notice that, right? So we're going to remove the first node. Let's talk about this list over here. Header.getNext. So header over here .getNext is going to give you this particular node, right? So this will be the node that we want to remove. Remember the input parameter over here, right? I'm just going to denote it as node over here. And how do we remove this particular node? Well, we're going to set the references, right? Let's try that. So I'm going to, first of all, I'm going to say node.predecessor. So we will get predecessor over here, and also we'll get successor over here, right, for this particular call. And then we're going to set the predecessor's reference of next into the successor. And we're going to set the successor's previous reference to the predecessor, right? Let's now do that. So now, rather than pointing to here for the next, it's actually going to point to the successor. And the previous over here is actually going to point to the predecessor over here. And we're also going to remove these two references, and they're going to be set to null, right? So that this node that we are trying to remove is going to be garbage collected, this one over here. Right? Hopefully, so far so good. So after this, we effectively have decreased the size of the doubly linked list by 1. So now we got node number 1 and node number 2, and also node number, header and trailer. So now after removing the first node, we only got 1 node left. So this will be the only node that we got left. All right. Let's try to call the removeFirst for the second time. Okay. If you try to do that, let's now see what's going to happen. Let me use a different color. Okay. So you can see we try to remove the first. And we're calling the removeFirst for the second time. And what's going to be the first? We're going to pass the header that get next, right? So header is still over here. It's dedicated. It never changes its reference. The next is really pointing to this node with mark, right? So this node is going to be the node that we want to remove. Accordingly, when you call the remove, as if you recall, we're going to figure out locally the predecessor and successor. What will be the predecessor? The predecessor will be the header. The successor will be the trailer in this case, right? So what we're going to do is this will be the predecessor and this will be the successor over here. And how do we do removal? Easy. We're going to follow the same steps as we explained before over here. So let's try that. Let me just show to you very quickly. So this is the node we want to remove. So that means this current node's predecessor is now going to set its next. Rather than pointing to here, it's now going to point to wherever the successor is. And for its successor node, for its previous reference, rather than pointing to over here, it's now going to point to wherever the predecessor is, right? It's really repeated execution for the same block of code. Right, let's do that. So for the predecessor, it's next. Rather than pointing to over here, it's actually now going to point to this particular node over here. Okay, let's draw a little better. Yeah, I think that's pretty good. And also for its successor, which is over here, its previous node is actually going to point to this particular successor node over here, right? And also make sure for the node to be removed, we're going to set its next and also previous, the next and also previous over here to be null, so that it will be garbage collected, right? This is the node that we're talking about, right? So after all these, what we ended up with is we got an empty list, because originally, before the very first removeFirst call, we actually got two nodes in the list. After calling removeFirst 2 times, so of course now we got an empty list. Let me try to highlight it very quickly together with you. You can see this is the header over here, and this is the trailer over here, right? And the next of the header is now pointing to this particular node, and the previous of the trailer is now pointing to the header. So that's why that's the only 2 pointers left. So that will be our empty list after 2 removals. And to really, in the interest of time, I'm pretty sure you got an idea. If you know, you can reach out to me. But again, I'm going to assign some exercise for you. Okay. So for this part over here, I want you to really trace the code. So this will be the list to start with, to see how you can actually call the removeLast for 2 times. So this will be the exercise for you. Ideally, you can do the tracing on both the paper and also Eclipse debugger to really step into to see how things will actually get executed line by line. All right, so that's about how you can use the remove method as a helper method in the removeFirst and also removeLast. And what's the running time, by the way, is really important to note. Of course, for each one of them is simply just a method call over here, so it's going to be dominated for the running time by the remove method over here. And the remove method we know actually is bigger of 1, right? We know that it's bigger of 1. So by calling the remove, is always going to be bigger of 1. And also remove is going to be bigger of 1. So for both of them, it's going to be constant amount of time, right? Just to make a note over here. Right, let's now go back to the slides quickly, and then we move on to removing from the middle. And if you take a look at the running time for remove itself, of course, it's constant. And what about removeFirst? We are only calling the remove. That one is going to dominate, which is going to be just constant. And also for remove the last. Now, this is very critical point. In the case of a singly linked list, if you try to remove the last, what you had to do was you have to use the getNodeAt helper method to get to the node, to get to the second last node, right? And then from the second last node, you can actually do the removal for the singly linked list. But getting to the second last node itself for a singly linked list will take linear time, as we explained before. But now, with the first extension about the previous reference for the doubly linked list, we are now able to simply call the remove helper method, and you will simply boil down into setting the different references. So that will still be constant. So that's so important to realize, right? We are able to improve drastically the performance for the removeLast for doubly linked node because we support the previous reference. All right, so the next one I want to talk about is about removeAt a particular position, remove at the middle. Right, let's talk about it also very quickly. Okay, so let's now move on to this. And again, I have set up the list like before. So this will be how I set up a list of size 3. Right, so I keep adding to the front. I add Tom, I add Mark, and I add Alan. Right, so that's the list. And I got 3 calls to the removeAt. I got this one over here. I'm gonna trace just one of them. Okay, so let me use let's say this one over here, and the other 2 I'll leave as exercise for you. Okay, so for this one over here, and also for this one over here, let me just write it down first as the exercise for you. So for these 2, I want you to really trace by yourself diagrammatically and ideally also in Eclipse to see the debugger. Exercise of tracing. Of course, for the best of your learning, paper and Eclipse. Right, that's the exercise. But let's now trace this single call together. If we want to remove at position 1, index 1, so we're going to say removeAt. And for the removeAt, all we're going to do is we simply just get to the node at index I. Think about what you have to do instead in the singly linked list. In the singly linked list, you have to get to the node at index I-1, right? And once you get to the index, the node at index I-1, you can set the pointers accordingly. That's the exercise I assigned to you for the singly linked list. So if you got any trouble with it, you should reach out to me. But in the case of the doubly linked list, you can simply just get to the node at exactly index I. Right? Let me just write down the contrast. Okay, so the contrast you really want to have is in the case of the singly linked list. And then we got removeAt. We actually call get node at, let me just write a little bit better, more legible. Get node at I-1 rather than just I. All right, let's now just singly linked list, and that'll be I-1, right? So important to see the difference over here. All right, so once we get to the node at index I, we can simply remove the node and pass the node as the arguments. Let's see exactly how that works. So now we got actually remove at index 1. So we'll get the node at index 1. Index 1 will be 0 and also 1, right? So I assume that the index for this header will just be -1. 0, 1, 2, and 3. Right? So let me just write it down. In terms of the index, it's going to be -1, 0, 1, 2, and also 3. Right? That's the indices. And let's now try to see if I want to get to the node at index 1. So this will be the node, right? So this is the node I want to remove. So this is the node that I want to remove. And how do I remove it? Well, in order to remove it, I need to set up the references. Well, before I do that, I need to identify what the predecessor is and what the successor is, right? So its previous is going to be the predecessor, right? Predecessor and also successor. It's going to be the predecessor over here. And also the next one is going to be the successor. So once we have got these, you can see now we end up in the same situation as this particular situation, right? There's one thing I want to point out to you, which you really want to think abstractly. So this is any arbitrary scenario that the remove helper method can really handle. This is definitely applicable to the very either this case over here, when we try to remove, let's say between, let's say the header and also, let me say that again. In this case, when we try to remove the first, when we remove the first, we might just be removing this, we're just removing this particular node, the first node. And when we are removing the last node, which will be the node over here, you can see both scenarios can also be applied to the arbitrary scenario for the remove method over here. That's the point I'd like to make. Right? That's why it can be used as a general helper method. And now in this case, for removeAt over here, so now we are trying to remove index 1. And the way to do it is we're going to set its predecessor's next reference rather than to here is going to point to the successor. And also for its successor, for its previous reference rather than pointing to here is going to point to the predecessor, right? The similar step. Let's now do that. So I'm going to do like this. The next for the predecessor is not actually now going to point to the successor over here. And for the successor, its previous reference is now going to point to predecessor over here. And you want to make sure for that particular node you're trying to remove, also set its next and previous to be null, right? So that's what we have done. So after removing the node at index 1 over here, so what we got is, you can see here, we got index 0, actually let me update the index. Index 0 is still here, but we no longer have this as index 1. So this will be index 1, and this will be index 2. That's what we have, right? Let me use a different color just to show what we have really updated. Okay, so think about no longer here, but this will be updated as index 1 conceptually, and this will be updated as index 2, right? And the references wise, you can see this one here is pointing to here, and this one over here is pointing to here. So we only got the first node, the second node, and trailer, right? That's not the third node. First node and second node, only 2 nodes left after removing one. Right, to really complete the rest for this one here, and also this one here, I'll leave that to you to really complete the picture, complete the implementation of the test. All right, let's now move back to the slides. What will be the running time for the removeAt? Well, apparently it's going to be dominated by this method call over here to really get to the node at index I. It seems like it will still be dominated as linear time, right? Let's now write it down. So you can think about this line over here is going to dominate the performance. This one over here. So this one over here is actually going to dominate the performance, which will be big O of n. It's going to be linear. All right. So you can see that even though we have introduced the previous reference, but in terms of the performance for add or removeAt, it will still be just linear. There's no improvement that can be made by introducing the previous reference. That's something to note. But for the removeLast, as we showed before, removeLast definitely has been improved from linear into constant. All right, so let's now do some quick exercises together.